Hello, so today we are talking about correlation, which is a word that you've heard before. You did this in middle school, so this lesson should be really easy for you. So what correlation is a pattern or a relationship that exists between two measures. So what that means is on an axis, we always have an x-axis. So we'll look at this one here. We have an x-axis and we have a y-axis. So the x-axis is measuring something. In example 1, it's measuring time. And a y-axis, in this case, is measuring calories. So correlation is the pattern or the relationship between these two things. So between time and calories, for example, in number 1. So what we have with correlations is that there are 3 different types. So hopefully you remember this from middle school. The first type of correlation is if you were to draw a line through the middle of your points. This line is going upward. So this is a positive correlation. It has a positive pattern. It's going uphill. So this one is positive. In this next example, there is no line that I can draw through those points. So this is called no correlation. No correlation. It means there's no pattern that relates the two things. It's not going in a line. It's just a blob of numbers, a blob of data. So there's no correlation for that one. But in this third one, this one has a negative correlation. So it's going downhill for this one. So that's why it's negative. So this pattern, this trend, this correlation is negative. Okay, so what we're doing this week is talking about patterns from data. We are out of the chapter of exponentials, so you guys did a great job with your exponential graphs and word problems over the last 2 weeks. So we are moving away from exponentials and into some data. So we're looking at some data, words, and statistics. So in this video, we're talking all about correlations, which is easy. So now I want you to find some notebook paper. And on number 1, I want you to write down if this has a positive, negative, or no correlation. So if you were to draw a line in the middle of those points, is that line going up, down, or no correlation at all? Okay, so on number 1, go ahead and write if it's positive, negative, or no correlation. Then number 2, it's comparing weightlifting. How many repetitions and how many pounds of weight? So in this one here for number 2, is this a positive, a negative, or no correlation? Very easy. Okay. Number 3 is a little squiggly, but I could draw a line through those points. I could have a line of best fit. I could fit between those points. So is that line that I just drew positive, negative, or no correlation? And then last but not least, number 4, can you draw a positive line, a negative line, or does it have no correlation? Very easy. So correlation is the pattern or the trend between our 2 variables. It's either going up, which means it's positive, it's dropping down, which means it has negative correlation, or you can't see a line and it's called no correlation. Very easy. So on your notebook paper, make sure you have numbers 1 through 4 written down as positive, negative, or no correlation. Okay, so now we're going to talk a little bit more about the line of best fit. So what that means is if I were to go out and collect data, I could graph my data. So in this first example, they're talking about Honda cars. So my y-axis is their value in thousands of dollars, how much money that car is worth. And my x-axis is the age in years. Okay, so I have a car that costs money, and we're seeing how much it costs over the years. Well, if we look at this data, all these blue dots are decreasing. This is a negative correlation. And the reason why is because as our car gets older, so from 5 years, and then it's 10 years old, 15, 20, as our car is getting older, its value is decreasing, which makes sense. A brand new car is gonna cost some money. And then as its age is increasing, as we're moving along in its age, its value is decreasing. So this has a negative correlation. So what we did is we drew a line that went through the middle of that data. If we were in school, we would have you guys draw the line, but since we're online, we're going to provide the line for you. So this line is called the line of best fit. The line of best fit has approximately the same number of dots above it as it does below it. So it's just a line that goes right through the middle of your data. So in this question, it says, when a Honda is 10 years old, what will its value be in thousands of dollars? So 10 years old. So this axis says years, and here's 10. So what I'm going to do is I'm going to go up to the line. Here it is. So that is the point on my red line of best fit for when it's 10 years old. So now it says, how much will it cost? Well, the value is my y-axis. So when this thing is 10 years old, it's approximately right there. So looking at my multiple choice, is it $9,000, $19,000, or $32,000? So it's between the 10 and the 20, definitely closer to the 20. So $19,000 would be my prediction. So we're using this line of best fit to predict the value of money that this car would be worth. Okay, not too bad. So we find what it's looking for, we follow it to its line, so 10 years, and then check your y-axis for where that was. Okay, number 6, so that's number 5. So on your paper, make sure you're writing 5B, $19,000. So that was number 5. You did 1 through 4 on that last page. Okay, now we're number 6. Number 6 says, about how many hours do you have to work in order to make $200? Okay, so we have $200. So this is a UPS worker. The y-axis is the dollars that he's earning, where the x-axis is the hours that he worked. So when this UPS worker makes $200, we want to know how many hours he worked. Okay, so I draw my line, I hit the line of best fit, and so then I look down and I see that this is 10 hours. So the correct answer is B. So $200 is right here. We go to the line, we drop down, and we find that number. So for 10 hours, he made $200. So now I want you to try number 7 and number 8. I'll read it to you, and then you try to get the answer. Number 7 says, when 25 TVs are purchased, what is the price per TV? Okay, 25 TVs are purchased. Then what's the price? Is it A, 400, B, 25, or C, 600? Next, number 8. When the temperature is 40 degrees, so when the temperature is 40 degrees temperature, how many customers bought ice cream? So from that 40, we're going to go until we touch the line, and then figure out what the x value would be right about there. Okay, so when that's the y value, look down to see what your x value is. So you should have answers for 5, 6, 7, and 8. Write the letter and write the number that it says there. So like for number 5, you put B, $19,000. For 6, you put B, 10. So try number 7 and number 8. Okay, last but not least, so this is the last piece. We have a couple more questions from video notes 1, and then we'll move over to video notes 2. So now what we have, we're talking all about correlation. So correlation is the pattern between two variables, two things. That pattern could go up, that pattern could go down, or there could be no pattern, no correlation. So now what we're talking about is something called the correlation coefficient. So what that means is that in statistics, we are looking at correlations, we're looking at patterns. So if we were to go out and collect some data, and we saw this pattern that looks like this here, then this is really good data. This is a nice straight line. That's a nice pattern. So in order to see how good our data is, how straight our line is, mathematicians made this thing called the R value. So what the R tells us is how straight your data points are. How good is our data? How close does those dots go to a straight line? So in this one, we're looking at the R for lines. This is linear data. We're looking at lines here. So what R means in this case, R is the value. And when we think of R, we think of a line that is really straight, a really straight line. So when we're looking at R in this chapter, that means we want a really straight line. So if I were to look at this example right here, and I took these numbers and I plugged it in the calculator, this line is pretty straight. So the calculator would tell us that this is a good line. These dots almost line up into a perfectly straight line. So it would have an R value of something like 0.98. Okay? So R values that are, like we think of it like test grades. If you made a 98 on a test, that means that you're a really good student. So this graph, this data, these points, they made a 98, which means they made a really straight line. Those data points lined up in a pretty straight line there. So this R value would be approximately 0.98. In the calculator, if we were at school, you would be able to see the exact R values for these. So what I know about 0.98 is that we call that strong. If it's closer to a 100%, if it's closer to 1, then it's a strong line. This is strong data. But what else we know about this is that these dots are going upward. They're increasing. So this is called positive. So this R value, 0.98, is a strong positive correlation coefficient. Okay, so let's look at the next one. So these dots line up in a really nice straight line. So in this one here, the dots are a little bit less straight than the first one, so that might be an R value of something like 0.95. Again, if we were in school and we had calculators, we would plug in the numbers for this data, and the calculator would tell us, hey, your R value is that this is 0.95, which is good. So if you made a 95 on a test, you're strong. This data is strong. This is good data. It's close to a 100%, close to that 1. However, this line is going down the hill. It is a negative correlation. So it's strong because it's a straight line, but it's negative, which means it goes down, which is fine. So that's a strong, because it's a 0.95 is a strong correlation, and it's negative, which means it goes downward. Okay? The next one. So when we look at this data, these dots, like they go upward, like there's a pattern, it's going upward, but these dots are not sitting on a very nice, perfectly straight line. See how these dots are kind of all over the place around the line? So if this was in the calculator, its R value would be something like we'll call it 0.65. Okay, so this is not very straight. It's not like a 98% on a test. This is more like a 65. Like, yeah, you kind of get it. It's in a line, but it's not a very good line. So what a 0.65 would be is that we call that weak. If you made a 65 in a class, that means it's a pretty weak grade. So this is a weak correlation. But the line is going upward, so it is positive because it's going upward. So if it's going up, it's positive. And if it's like a 0.65, that's pretty weak. So we'll do one more like that. So in this one here, this makes a pattern. The pattern is going downward. So we know that this is a negative pattern. This is a negative correlation coefficient. Ooh, and this one here was negative, so that should have had negative. Whoops. So because it's negative, that R value will have a negative sign because it's going down. But this is not a very straight line. Like these dots are kind of all over the place. They're not perfectly lined up in a straight line. So this data is pretty weak. We're going to say that if you plug this in the calculator, its R value might be something like 0.58, which means that that's pretty weak data. It's not in a perfectly straight line. So the R value would tell us, it's not a very good line. Okay, so the biggest part of this lesson, if you're a little confused still, that's okay. But the biggest part is what we're doing in questions 9 through 16. So in question 9, the first thing we ask ourselves is this a positive or a negative number? Is R a plus, is it positive, or is there a negative sign? So in number 9, this is a positive number. 0.48, that's positive. That's not a negative. If you made a 48 on a test, are you a strong student or a weak student? You're pretty weak. Okay? And so here's the key to help you up here. It says it's strong if it's a 0.70 and up. So anything 0.70 to a full 100%, 1.00, that would be strong data. That's good data. However, anything less than 0.70, like 0.48, that's a weak student. That's pretty weak data. So what this would look like, just as an example, is that this would be positive. So it's going up the hill. It's positive. But these data points are kind of all over the place. They're not in a perfectly straight line, which is why it's called weak. Okay, it's positive because this is a positive number. However, 0.48, that's not a very good test score, so it's not a very good line, so we call that weak correlation. So the correlation coefficient is the R value. If we were in school, you would have calculators and be able to see how that works in the calculator. So all I need you to know is that it's positive, because that's a positive number, and it's weak, because a 48 is pretty weak. So try number 10. So number 10, is that number positive, or is that number negative? A 96, would that make you a weak student or a strong student? I'll give you a hint for number 10. I'm going to graph this for you. So 0.96, that's pretty good. It would be like maybe a little off of the line. That's a little too off. So 0.96, if that's my R value, R tells us if the line is really straight. So with linear functions, these are lines. It tells us if it's a really straight line. Okay, so number 10, if it's positive or is it negative? Is that a weak or a strong correlation coefficient? Okay, let's look at number 11. Number 11 has a negative in it. Oh, look at that. There's a negative there, which means that this graph is going to go in the negative correlation. It's going down the hill. That's a negative graph. Okay, this has 3 numbers. Don't let that scare you. I'm just going to cross out the back number. I don't care about that back number. I like to think of these like test scores. Makes it a little bit easier to understand. So if you made a 92 on a test, ignore that it's negative. That doesn't matter. If you made a 92 on a test, that's a strong grade. That means that you are a strong student. So what that means is that this is a negative line. It's going down the hill. It's negative. But a 92, that's good. That's a strong line. That's a pretty straight line. So number 11 is negative because there's a negative sign. And a 92 would be strong. Okay, try number 12. So again, in number 12, you only need 2 numbers. You don't need this back number. So 0.65, is that positive or is that negative? Is there a negative sign on 0.65 or is it positive? If you made a 65, is that weak or is that strong? You can use this to help you understand weak and strong. 0.70 and above is strong. Anything less than 0.70 is weak. Okay, a couple more. 13. 0.82. I do not see a negative on that 0.82, so I'm going to say that that is positive. 0.82 does not have a negative sign. Therefore, this line will be positive. It will be going up the hill. Positive correlation. An 82 on a test, that's good. That's strong data. 82, that would be strong. Okay, so a graph that has a correlation coefficient of 0.82 means it's positive. It's not going to be as perfectly straight as my last one. So it might be something like this. It might swivel off the line just a wee little bit, but it's still pretty straight. 0.82, positive, strong correlation. Okay, try number 14. Positive or negative, strong or weak. Okay, number 15. 15 has a negative sign, so guess what that means? This graph is going to have negative correlation. It's going downwards because it's negative. A 99, again, don't worry about the negative sign when you're looking at weak, strong. So 0.99, that's really good. That's really, really strong. If you made a 99 on a test, that means you are awesome. So that is strong correlation. So that graph, it's negative, so it's going down the hill. But 0.99 is like really, really straight. So that data would sit in a really straight line. 0.99 is really good. Okay, last but not least, try number 16. Is that positive or negative? Is there a positive sign or a negative? And then is that weak or is that strong? Okay, that concludes video notes 1. Video notes 2 is nice, short, and easy, so you can roll right into video notes 2 if you want to, but make sure you get that done this week. Remember, all of these go in as grades. So now that our grade books are open, make sure that you're completing the entire weekly assignment. Alrighty, so go ahead and head over to video notes 2 when you are ready, and we will talk to you here soon.